um, were faced up basically, and then a maximum face down. And it was a minimum or facing up when our A value was positive. It was a maximum face down when our A value was negative. Also, some things I want to review about quadratic equations in factored form. The nice thing about factored form, remember, we factor it so we could find the zeros, or basically where it crosses our x-axis. So this x minus 3x plus 4 gives us the zeros of -4 and +3. Vertex form was nice in itself, and then it gave us the vertex. So the vertex here is 1, 2, which were given here by HK in our vertex. And also, standard form here is nice because it always gives us the C value always gives us the y-intercept. So that's why it's crossing here at 0, 2 at the y-intercept. I wanted to talk briefly about these things because we are going to use this factored form and somewhat of standard form to really visualize, broaden our spectrum and visualize the quadratic. The polynomial, not just quadratic. So we're going to be able to do this with cubic functions, with quartic functions, with quintic functions, you name it. One thing I want to discuss is end behavior. End behavior is how the graph starts and ends, leading from left to right. So in this case, this parabola has up end behavior because it starts up and ends up. This parabola has down end behavior because it starts down and ends down. This parabola is up because it starts up, ends up. And I will address end behavior with more. Now, very briefly, we are going to review factoring. Remember, the biggest thing with factoring is the first thing you want to do is see if there's a greatest common factor, and we need to remove it. Okay, so in this first one, you might look at it and say, no, there's not, but there is, because each of those terms has at least one x. So we can factor out an x. Okay, so we take the x out. X squared divided by x is just 1x, and x divided by x is just 1. So it factors to x times x plus 1. And then there's nothing else we can do. Here in parentheses, it's not a quadratic, so it can't potentially factor further. So that's it, we're done. Now let's look at the second one here. Do we have a greatest common factor there? We do not. All terms don't have an x, and all of the coefficients aren't divisible by the same number other than 1. So let's go through our guess and check method. So remember, that's 2 parentheses. Okay, and then it's, all right, what are factors of my ax squared? So what can I multiply to get 3x squared? And we can multiply 3x times x, and that's our only option. So let's put that. Okay, well, after that, it's what are the factors of our C term, which is 1 here. One of the factors of 1 are 1 and 1. So let's put that there. So we put that there, and then it's a positive 1, which means the only way we can multiply that is 2 pluses or 2 minuses. So we look at our B term, which is 4x, a positive 4x. So clearly both of our signs have to be pluses. And then we can check our OI. So we check the outside. 3x times 1 is 3x. 1 times x is 1x. 3x plus 1x is 4x. So these are the correct factors of 3x squared plus 4x plus 1. Why don't you go ahead, pause the video, and attempt this last one. The correct answer for that is 2 times x minus 3 times x minus 1. If you got it, you can skip ahead. If you missed it, listen to the following. So you have a greatest common factor of 2, so we need to factor that out. So we do that, and then when we divide everything by 2, we have left with 2 parentheses x squared minus 4x plus 3. So then what's inside the parentheses is a quadratic, which means it could potentially be factored further. So we have to factor that further. X times x gives us x squared. And then our only factors of 3 are 1 and 3. And so we put those in, and we look at it's a sum. So we know the signs are going to be the same. So if we look, the only way we can OI to a -4 is if both signs are negative. So let's check. X times -1 is -1x. -3 times x is -3x. -1x plus -3x is -4x. And it has to be this in order to get full credit. Gang, why are we reviewing factoring? That was last chapter. Well, like I told you before, we're never done factoring. That's one of my most favorite topics in Algebra 2 or in math in general. So with 6.2, what we have to do is we're going to look at polynomials and we want to factor them. So here are two different polynomials. Let's write them in factored form. I'm going to do the second one, and then I'll have you guys pause the video and do the first one. So let's first look at this. We have y equals 6x to the fourth minus 15x cubed minus 36x squared. You might say, well, hold on. We've never factored a quartic function before, so I'm done. Well, you're right, we haven't. But if you look at this, what do each of our terms have? Remember, think greatest common factor. You might say, well, they're all divisible by 3. Yes, they are. But they're also all divisible by x. Actually, they're all divisible by x squared, because each term has at least an x squared, or at least two x's in it. All right, so let's factor out our greatest common factor. Now that looks better, because now we have a quadratic in our parentheses and we can factor that. So let's go through the steps. What are my factors of a of 2x squared? What are my factors of negative 12? And then let's check our OI. Okay, the only way we can get 2x squared is 2x times x. Factors of 12, we do have quite a few different ones we can choose from here. We have 1 and 12, 2 and 6, 3 and 4. If you notice, 3 and 4 is what works. So I put those in. It's a negative 12, so our signs have to be different. And it just so works out that if we have negative 4 times 2x, we get negative 8. And positive 3 times x, we get positive 3x. Negative 8x plus a positive 3x gives us negative 5. So there is your factored form. Go ahead, pause the video and complete that first one. And there you have it. It's y equals 2x times x plus 3 times x plus 2. And did I catch any of you on this one? Because I am sure there's a handful of you that did x minus 6 and x plus 1, because it always to, or x plus 6 and x minus 1, because it always to positive 5. The problem is, because your signs are different, a negative 6 and a positive 1, it will multiply to negative 6. And it has to has to multiply to positive 6. So your signs have to be the same there. Okay, finding zeros. You might say, well, we did this in chapter 5 too. Yes, you did. You found zeros of quadratic functions. Now we're going to work at finding zeros of polynomial functions. When we found zeros of quadratics, like we reviewed at the beginning, but also then it was our x-intercept, right? Or where it crosses the x-axis. And to do that, the best way to do it was to write our quadratic in factored form. And then once it was in factored form, we could easily find our zeros. Well, look, each of these functions are already in factored form. All right, so we can easily find our zeros. So I'm going to do this second one again, just because I feel it's a little bit harder than this first one. So I'm going to switch them up. So we have y equals x times x minus 7 times x plus 3. My zeros here are 0, 7, and negative 3. How'd I get that? Set each factor equal to 0. This x by itself is a factor. So x equals 0, so 0 is one factor. X minus 7 is a factor, so set that equal to 0, add 7 to both sides, we get 7. X plus 3 is a factor. Set that equal to 0, we have to subtract 3 from both sides, we get x equals negative 3. So you have your factors of 0, 7, and negative 3. Or sorry, we have our zeros, so those are our x-intercepts. Now using that, we can graph this function. You might say, well, I've never really seen too many graphs, especially of functions that look like that just says 3 dots, and you're right, you won't. So what you can do from there is you could either plug this in your graphing calculator and see what it should look like, or we can use a trick about end behavior. And because this function is positive, right, if I multiplied all of it out, we would have a positive x cubed. Because it is positive, we know it's going to end up. And since it's an odd function, what I mean by odd function is it's a x cubed. So because it's odd, I know it has to end differently from how it starts. So we know it's going to end up here. So that means it's going to start down here. So let's graph that. You might be saying, well, why are there two lines there? Basically, we don't know exactly how it's going to look using that end behavior rule. It could be just somewhere up over it or somewhere below it, and you can just test it that way. I just know it has to start down here and end up here. So we're going to go from decreasing to increasing, and then increasing to decreasing, and then decreasing to increasing function. It's going to look like that. Why don't you go ahead for this one, find your zeros, and then attempt to graph that as well. With those zeros of 2, -1, and -3, and it being a positive function, it's going to look something, a positive cubic function is going to look something like that. To write a polynomial function in factored form with the zeros that were given there. So with this, you might say, well, how in the heck can we do this? I've never learned this. You're right. But since we know the zeros, we should be able to determine the factor. And since we know the factors, we can write it in factored form. So it's kind of one-step problem here in a sense. So looking at this first example, we have x, so our zeros are -4, -2.5, and 1. So the factors would be, okay, so we had our zeros. X is -4, x is -2.5, x is 1. I just said, all right, well, we could add 4 to give us x plus 4 equals 0. We could add 2.5. We could subtract 1. So we would have this. Those are your factors, right? Don't we take each factor when we're finding the zeros? We take each factor and set them equal to 0. Well, here's each factor set equal to 0. So our factors are x plus 4, x plus 2.5, and x minus 1. And notice I have this question mark over x plus 2.5 because we don't write factors that way. You know that. You've never seen them written that way. So what is that as a fraction? Well, 2.5 is 5/2. So I know that this factor actually needs to be 2x plus 5, because when I solve this, I'll subtract 5 and then divide by 2, giving us the -2.5. So there's your polynomial in factored form with those given zeros. So go ahead, pause the video and try the second example. And there you have it. It is x plus 2 times x minus 3 squared equals 2y. And all of the work is shown there if you need to pause it and check it out. Okay, here, multiplicity is probably the easiest concept, but yet so many people get confused with it. So let's talk about it a little bit. Find the zeros of each function, state the multiplicity of multiple zeros. All the multiplicity is it's telling you how often that zero is going to occur. So pretty much the multiplicity is just the exponent. Okay, so let's work through an example of this, and then you can try one on your own. So here we have f of x equals x to the 4th plus 6x cubed plus 8x squared. Well, first of all, I have no clue what those zeros are. So the first thing I'm going to have to do is factor it in order to find them. And then after we have it factored, we'll be able to find the zeros and determine their multiplicity. So so here we take out our greatest common factor of x squared. Once we do that, we have a quadratic remaining, so we see if we can factor that further. It just so happens that we can, because when we check our OI, we get 2x plus 4x, which is 6x. So this polynomial in factored form is f of x equals x squared times x plus 4 times x plus 2. Now we have to state the multiplicity of multiple zeros. So our zeros here are 0, -4, and -2. Okay, because we set each of those factors equal to 0. The only problem is this is x squared, which actually means that there are two x's there, x times x, which means 0, the 0 of 0 occurs twice, just like that exponent says. So we write the multiplicity, so 0 has multiplicity of 2, but the other two zeros do not. So it's just -4 and -2. And it makes sense because a quartic function should have 4 zeros. However, it only crosses the x-axis at 3 different times. So this is a repeated 0. So 0, 0, and then -4, -2. Go ahead, pause the video and try that last one on your own. Nice, it's already factored for you. So all you got to do is state the zeros and their multiplicity, if any has them. And those are your zeros: 2, -1, and 1 with multiplicity of 2.